So till now we have seen that there are various NDT techniques which are used to detect cracks in the materials or the components, and if we are unable to detect the cracks in those components, then those cracks will lead to the failure of the component. So now the question arises that why these cracks are formed, what is the mechanism behind the formation of these cracks. So here you can see these two pictures, where the picture on the left hand side shows that a metal rod has been broken down into two parts, and you might have struggled with the opening of a plastic sachet. So if a small opening is provided in the sachet, then it is easy to open it. So you can see here that a small crack in this sachet will lead to the easy opening of this sachet. So if we have to define, or if we have to understand the failure, so firstly we will define it, that what actually a failure is. So it is the inability of a system or the component to perform its required functions within the specified performance requirements. Means if a component or the system is not performing up to its full efficiency or up to the required performance criteria, then we can say that the material has been failed. So here you can see this picture, that a cargo ship has been broken down into two parts. So it has been failed, and it is a 34,000 ton cargo ship which has been uh, found on the Japanese coast, which is a Panamanian registered cargo ship, and it is a recent incident which has happened. So you can see that this incident has led to so much economic loss, and also it is it has also put um, the sea species in difficult situations. So we can say that the failure is an undesirable event. Why it is undesirable? Because it put human lives in jeopardy, or you can say that it can lead to it can cost human lives. It can also lead to economic losses, huge economic losses sometimes. And uh, instead of economic loss and human life losses, it also interference with the availability of the products and services. So suppose if this ship uh, was supposed to carry out this oil or any other cargo to the required location, so as it is already filled, so it has interference, it has produced the interference with its the products and services which it was supposed to provide. And what are the usual causes of the failure? So the usual causes are sometimes the improper material selection and processing. If the designer of a component is unable to select a good quality material, then that can lead to the failure. And if there is a inadequate component design, means if you have designed a specific component and you have not considered the required design criteria, means how much load that component can bear, so that can also lead to the failure. And this third part refers to the in service failure. Means if you are using the component in a way which in which it is not supposed to be used, means if you are misusing the component, that then it can also lead to the failure. So what are the mechanisms of failure? So the important mechanisms of failure are: the first one is the fatigue. Fatigue is is a failure which is produced when a component or is subjected to cyclic loadings. Mean a loading or a mechanical loading, it can be a thermal loading as well. Means if external stimulus is there and that external stimulus is cyclic in nature, then that leads to the fatigue failure. Then there is creep. Means if there is a time dependent constant load, means if you have a component and it has been subjected to a constant load, then that component can fail as that component is subjected to that constant load for a longer period of time. Then there is buckling. So if there is a slender member, or if there's a vertical member which deflects laterally. So here you can see from this figure, so these are the steel columns, vertical columns, so which has been deflected laterally. So this phenomena is known as buckling. So it generally happens in our structural member. So if you have a plastic ruler in your hand, and if you will put the ruler between your between your thumb and your index finger, and you try to bend it, then the phenomena which will happen is known as buckling. Then there's corrosion, which we are all aware of, that it is a natural process which converts the refined metal into some more chemically stable forms, such as its oxides, hydroxides, carbonates, or sulfides in some cases. So here you can see this gear assembly which has been subjected to corrosion, and if any component is subjected to corrosion, then it will obviously interference with its proper functioning. So in infrastructures, the corrosion can happen in underground pipe. It can also happen in terms of sea corrosion, means if you have infrastructures which are placed in sea. Likewise, if you have some uh, bridges across sea, or if you have some oil platforms which are immersed in sea, so that can lead to the sea corrosion. AC drain also produces corrosion, and in concrete reinforcement this corrosion also occurs. So these are the mechanisms which we should take care of while designing a component, and these are the mechanisms which generally lead to failure of any component. So we will also see each and every part like fatigue, creep, buckling, and corrosion separately, that what is the actual mechanism behind it. So here this figure shows the failure of a component when it is subjected to fatigue. This one shows buckling, and here it is shown for the corrosion. So I hope you have got an understanding of the mechanisms from which crack arises, and if it is not taken care of, then it can lead to a catastrophic failure. Thank you.